Okay, so this is the second demo, and this one I really just want to talk briefly about the Bureau of Labor Statistics. So, what do we get from the Bureau of Labor Statistics? A couple of things that are really important are the Consumer Price Index and unemployment data. Now, actually, a lot of those data are available other places in the census, for example. But this is the source of that data. So consumer price index, as I talked about in the lecture, is really just an indicator of inflation. And of course, unemployment becomes important in a lot of policy arenas because, a lot of policy actually is directed at trying to either lessen unemployment or actually help people who are unemployed. And so, like the census, there's a ton of data here that we'll only scratch the surface on. If you go to the BLS, you can see there's subjects, and so here you see things like the Consumer Price Index, the Producer Price Indexes, and others. Pay and benefits, you'll see employment costs. Actually, this is where another indicator resides called the Employment Cost Index, which is an indicator of how much it costs firms and governments and others to employ people. And then it talks about all kinds of areas with regard to pay and benefits, which would be useful for some projects. Then unemployment, it talks about the national unemployment rate, state and local unemployment rates, which can come in handy, unemployment research, and then it talks about employment. So employment and unemployment are actually two different looks. I really just want to talk today about CPI and give you a little bit of a demo on the use of CPI. Now, that should be under top picks, which is where you'd find CPI. But I wanted to get some historical data, which I was having trouble getting. So here it is. I actually ended up using the search. So CPI for all urban consumers, that is CPIU that I referred to in the lecture. So I checked on CPIU, I hit retrieve data, and what should pop up is this table right here. So this goes back all the way to 2009. I can actually adjust this by going back to certain years. I'll go back to 1980 on this one and hit go. And so it goes back to 1980 and it gives me the month by month CPI. Okay, so in this one, the reference year, the 0 year is, or the 100 year is around 1984. So it says the base period 1982 to 84 is 100. Okay, so we talked about that a little bit, I think, in the lecture. So a couple of things are important here. One is if you're going to compare CPI data, use the same month to compare year to year. Don't compare the CPI of January 1980 to June 1984. Don't compare the CPI of, the middle of the year 2016 to the end of the year in another year. Use the same data. So this says half one, half two. These are the averages. So I would choose, for example, December or half two to select that year as my CPI. For the exercise that I'm about to do, I typed in historical CPI here in the search function, and it gave me this chart. This is what I used to show CPI data for the annual averages. See, this one starts in 1913. From the annual averages all the way out to 2017. Okay, so again, what is CPI? CPI is really a basic look at how prices are inflated over time. Okay, so that's great. So how do we use that data? And that's where I want to go into a little bit of a demo. Okay, so here is a chart that has consumer price index for CPIU, as we discussed, from 1980 here all the way forward to 2017. Okay, So what we can see in this is that this yellow should be right about here. Cover all those. So that's the 0 year. So I made 1983 the 0 year in this. So what this says is that prices from this point forward generally inflate, unless we had, rapid deflation or some kind of depression. The prices will actually inflate year to year, typically in a normal economy. Okay, so what this means is that prices from the base year are going to go up by this much by 2017. So that's about 145% generally, based on this market basket of goods. But sometimes it actually helps to rebase to a different year, and I'll show you an application of that in just a second here. So on my spreadsheet, I have this budget example. Okay, so this is a mythical budget here, sort of. I had this budget from a government agency, partial budget, I should say. So from fiscal year 1998 all the way out to fiscal year 2017. And I had 3 programs in this government agency: Program A, Program B, Program C. So this is how much was budgeted for Program A in fiscal year 1998. This is how much was budgeted in fiscal year 98 for Program B. This is how much was budgeted for Program C in fiscal year 1998. And so I took this budget and I extended it all the way out to fiscal year 2017 for each of those programs: Program A, Program B, Program C. So what we have here, these dollar amounts all through here, are what we call the nominal or the current dollars. So in current dollars in 98, it was $41,255. Get all the way to 2017, and we see that the same program was budgeted $74,750. So it's grown. All right. And as it turns out, each of these has grown in the nominal dollar sense over that 20-year period. Okay, so how much has it grown? So a couple things to keep in mind when you're doing analysis of data is you really want to be able to talk about how much budgets might grow. So in a nominal sense, for Program A, it experienced an 81.19% growth. Program B experienced a 58.95% growth, and Program C experienced an 85.3% growth. Okay, so how did I get those? And I think you should all know this formula, and you probably do. So just to track the growth of something over time, I made this factual statement that Program A grew by 81.19%. How did I determine that? Just by this simple formula that I put into my cell there, which is the ending period number minus the beginning period number, in parentheses. That sum is divided by the beginning period number. So that gives you the growth, right? So it's ending period minus beginning period, all divided by the beginning period. And so what that tells me, oops, I messed up there. Okay, there it is. What that tells me is that I'm going to have to fix that. Let me copy that formula in there again. Okay. What that tells me is that growth was 81.9%. Okay, so that's interesting. But what is also interesting is actually, if you have a long budget period, is understanding how much that grows year to year, and that gives you sort of an average annual growth that can actually help you identify outliers, outlier years, for example. So how do I do that? So that's a formula that's right here. And that formula says you take the last period over the first period, in parentheses, you raise that to the power of 1 over the number of periods, so there's 20 periods in this, minus 1. And that gives you the annualized growth for that. So what we see is, on an annual basis, program A grew by 3.2%, 3.02%, I'm sorry. Program B grew at an annual average of 2.34%, and program C grew at an annual average of 3.13%. Okay, that's all well and good, but keep in mind, all that is in nominal dollars. But I wanted to know what the growth rate was in terms of dollars stated in terms of a reference year. So our base year was 1983. So I wanted to know what the growth rate was if I converted all these dollar figures to 1983 dollars. Okay, so how do I convert all the dollar figures to 1983 dollars? So it's pretty simple. All I did here is I copied all this information and put a new chart in here. Then I copy my CPIU figures with 1983 being the 100 or the base year. So how do I do that? I just go back here, starting in 1983 through 2017. I just did a copy here. I said copy. And then when I got here, I said I did a paste, and my paste is, I use the paste special function, and I hit values and number formats, and I make sure I hit transpose because it takes that column and it transposes it to a row, and it puts it in right there. Okay, so I got to go back. I made a mistake. It's $1983, but it starts in 98. So let me go back here, change this. Starting in 1998, my CPIU numbers, I'm going to copy those again. Paste special, values and number formats, transpose, boom. Okay, so what that did is it changed this. How did it change that? Because for each one of these I put in a formula, and my formula is this. To determine what the value of this number, this nominal number in 1983 dollars was for 1998, I said my formula is I take this number and I multiply it by the CPIU divided by 100. Why do I divide the CPIU by 100? Because it's an index number. 163 is not really 163. You have to divide it by, it's actually 16.3%. So that's why you divide it by 100. And it's the index is stated like this, multiplied by 100, because it's easier to say the CPIU is 163 than 0.163 something or other. So to change this to the constant dollars for 1983, I simply take this number, multiply it by this factor, which is divided by 100, and that gives me this. So then it's a simple matter of copying this formula into these cells and copying across. And now I know in 1983 dollars what the value of these are. And here I see, in terms of 1983 dollars, the program actually grew by a lot more in constant dollars. Program A grew by 172%, B by 139%, and C by 178.65%. And the annualized growth rate average obviously increased as well. Okay, so that's 1983, and that's really fascinating. But let's say we're in the budget year 2017 or so, and we want to know how much it grew in closer to current dollars. Well, one thing we might do is we might want to say, okay, we knew how much we were spending in 1998 as our beginning year. What if we wanted to say, how do all the subsequent years compare to that amount? So again, it's easy to do. We have to rebase our year. So we know that our base year is around 1983, as I indicated earlier. That's our base year for our CPI in this example. So how do we rebase our CPI? Okay, so for my chart here, here's how I rebase CPI. I know I want to rebase in this one to 1998, and I'm going to get to 2015 in a second. But for this one, I want to rebase to 1998. So 1998 becomes my new base year. So 1998 is right here in row 24. So what I do is I take the current CPI for this year here, 1980, and we divide that by my new base year, which is 1998, which is down here in B24. So I simply say B6 divided by B24 in parentheses times 100 to get a new CPI base. Okay, so for those of you who don't mess around with Excel very much, you might be wondering why I put those little dollar signs in there. If you put a dollar sign in front of a cell reference in Excel, like I put a dollar sign in front of the B and a dollar sign in front of the 24, that means that when I copy formulas, it won't change this, because typically if you copy a formula, if I copy a formula from here, it's going to change the cell references to the new cells. But if I put those dollar signs in front of it, it won't. So then all I did is I take this formula and I say copy, scroll all the way down my list of CPI numbers here, and I'm just going to say it's a paste special, but it's a paste formula, which is that one there. It changes that to that formula. So now I can go back to my budget example. I'm going to do the same thing I did before. I'm going to take my 1998 number, which you see here is 100, because now my formula was successful. I rebased my CPI to 1998, meaning that 1998 is my base year. I'm going to copy this, my CPI numbers here. And I'm going to do another paste special here. Values, transpose. So now I apply the same formula here. I want to know what all these values are in 1998 dollars. Now this one's going to stay the same because it's 1998, right? So the formula is I go back up to my original set of budget numbers. So it's C5, this is cell C5, times C16, which is my new base CPI number, divided by 100. So that's going to mean that these three stay the same because that's my base year. But all the others are going to change. And so what I know is that when I spent $112,409 in FY17 for this program, that nominally I spent $74,000, that would be the same as approximately spending that much money in 1983 or 1998, I should say, $1998 for that program. So the last thing I did was I said, okay, I'm working on my budget and I want to know what those dollars are in really current years. So I said I was working on my budget for about 2017, a couple years ago. But so I wanted to know what the dollar numbers would be expressed in 2015 dollars, because that seemed like a fairly close year, and that would give me an idea of how much the program costs. So again, here I rebase my CPI, for which the base is 1983 approximately, to 2015. So how do I do that? Same way. I take, here I am in 1980 at the beginning of my chart, I take B6, which is 82.4, divided by B41. B41 is 2014. Oops, I made a mistake. Did I say I was doing this in 2015 dollars or 20? Hold on a second. 2015 dollars. So I found my own mistake. So that did change slightly. So instead of B41, that's B42. So let me just change that. It's going to change my chart slightly, which is fine, and I will fix that in my attachment in Canvas. So I'm going to copy this, put this here. I'm going to say paste special, or hold on, let me do that again. Okay, here's my first converted number. Copy that, scroll down this column, go over to paste. I'm going to paste the formula. Then I will take from my budget years in question from 1998 forward. Having some mouse issues. From 1998 forward, copy this. Come to my budget example. Another paste special. Values transpose, so it makes it in a row. Go across there. Now I know this changed because I used the same formulas there. You saw those change quickly. So same formula. I'm taking the original nominal numbers. Remember, this budget up here is nominal. And using my CPI index number to change. So what does this tell me? What this tells me is in 2015 dollars, my program that I nominally spent 74,000 on in FY17 in 2015 dollars is 76,000, but in 1998 it was 28,000. So actually, I still didn't really spend as much in 1998 that I said I did. So that's a practical example of how to use the CPI to determine that. So just for review, what I'll tell you is I'd like you to actually mess around with the website, the BLS website, and look at CPI to get a feel for what it's giving you. But then my example should help you with the exercise. I include this spreadsheet on Canvas for you to use, and so please let me know if you have questions on that. So that's the end of this demo. Thank you.